So we're going to be looking at static rigid bodies, which means stationary solid objects. So recall that stationary objects have a resultant force of 0 and a resultant moment of 0. And we're going to include in the context of this section also frictional forces, where the friction is the coefficient of friction multiplied by the normal reaction force. And also it's important to remember that the normal reaction force is perpendicular to the surface that it is touching. So in this case, we have a uniform rod AB, mass 40 kilograms, length 10 meters. So uniform means the weight goes through the center of the rod. The mass 40 kilograms, which means the weight is 40 g. The length 10 meters, so the weight goes through 5 meters of this. With end A on rough horizontal ground. It's rough horizontal ground, which means that we have a frictional force in this direction, which is going to be our coefficient of friction multiplied by our reaction. This is our point A. And we have a smooth peg. So if this goes to B, 10 meters long, we have a smooth peg C, where AC is 8 meters. So if the peg here is C, we have 2 meters here and 8 meters in the rest, but we have our weight of 40 g acting 5 meters up. So 5 meters and 3 meters there. And the rod is in limiting equilibrium, which means our frictional force is the maximum friction that we could have before it starts to move. And we have an angle of 15 degrees to the horizontal. Find the magnitude of the reaction of C. So the reaction at C, I'll call N. That's this. Here it's perpendicular to the surface of the peg C, which is perpendicular to the rod itself. Okay. So first thing I'm going to do is to think about moments. I'm going to think about moments about A. The reason I'm doing that is because I'm not interested in finding R or mu R right now. I'm only interested in finding the reaction of C, which is N. So if I do moments about A, I can essentially cancel out the R and mu R because their perpendicular distance from A is 0. And when I take moments about A, let's think about clockwise moments first. We have our 40 g multiplied by its perpendicular distance from A, which is going to be this line here, which is going to be 5m cos 15. And then we have an anti-clockwise moment. So that's going to equal, because it's in equilibrium, our anti-clockwise moment of n newtons, and the perpendicular distance of n from A is going to be that 8 meters. Sorry, this is meters, isn't it? So we don't have m there, it's just 5. So it's n times our 8 meters. It wouldn't matter anyway, because the m, if we had m, it would have cancelled out, so it's 5. All right, so 40 times 5, so we have 200 g cos 15 is equal to n times 8, or 8n. So we have 25 g cos 15 is equal to n. And if we do that calculation, 25g cos 15, so 25 times 9.8, remember it's 9.8, which is what we use in maths instead of 9.81. So we get n is 236.65, and because we use g to 2 significant figures, let's do the same for n. So we get 240 to 2 significant figures. So the magnitude of the reaction at C is 240 newtons. The coefficient of friction between the rod and the ground. This is where we need to start thinking about resolving forces horizontally and vertically. And when we think about it as well, we have our normal reaction at the peg has a horizontal and vertical component. You You can use normal geometry to figure out that that angle there is 15 degrees, just like the angle down here. And then you've got this here, which is going to be equal to n sine 15. We've got our value for n. I'm going to use this more accurate version for the rest of the time. And we also have our vertical component, which is going to be n cos 15. So let's think about horizontal first. Horizontally, we have mu r is equal to n sine 15. Now n times sine 15, I can just do that straight on my calculator right now. It's 61.25. And then vertically, we have r, and we also have n cos 15. I can do that on the calculator as well, pretty quickly. So 228.588 is going to equal, because we're in equilibrium, 40g. So from that, I can calculate my value of r here by doing 40 times 9.8 and taking away the 228 answer to give us 163.411888. So now you can see if I do my mu r divided by that value for r, I can get my value for mu. So that's 61.25 divided by our 163.411888. When I do that, I get a value for mu as 0.3748, which is 0.37, so two significant figures. And therefore, we found the coefficient of friction. So all of these questions, it's about resolving forces vertically and horizontally, but also taking moments about certain points. Make sure you try and choose a point that you take moments about that makes things easier for you. Sometimes there'll be points that if you take moments about, it doesn't do anything for you. So think carefully about where you'd like to do it. There might not be a right or wrong place to take moments about, but there might be one. So just be careful when you choose.